we go. Today's objective, I can solve and graph one variable inequalities. And just to emphasize, we started the review yesterday, and our new concept that we're working with is one variable inequalities. And we went over the definition and examples. On examples, we said one variable inequalities are statements where two expressions are not equal to each other and contain one unknown variable. And I asked you to underline where it said expressions not equal to each other. Expressions not equal. What does that mean? Well, let's see. Here I gave you guys x plus 2 over here, and this is an algebraic expression. This is a numerical expression, 25. And what the inequality symbol says that one of them is greater than the other, so they're not equal. Here I have a numerical expression. Here I have an algebraic expression. Once again, one of them is greater than the other. And the same thing with these. If you notice, throughout all of them have inequality symbols. They do not have equal signs. I gave you none examples. I said copy these down. Some of the none examples I gave you were x plus 5 minus 25, 12 equals x minus 8, x squared plus 5 greater than 30, and 4x plus 6 less than or equal to negative 2y. And I asked you to share with your neighbor in regards to why do you think these were and why were these non-examples. And some of you said, well, this first one is an expression. Right now we're looking at inequalities. Yes, it's an expression because it doesn't have equal signs or inequality signs. The second one is an equation. Right now, once again, we're looking at what? Inequalities. The third one is a one variable inequality, I told you, but right now we're looking at the ones that don't have exponents greater than 1. So right now, if you notice, all of these have an exponent greater of 1, m has an exponent of 1, a1, y1, x1, all these the same. So once we get into exponents of 2, it becomes a quadratic. Right now, we're not quite there yet. That's why I put it in the non-examples. However, this last one, it is an inequality, but what does the definition say for one variable inequality? It has to have only one unknown variable. How many does this one have? 2, x and y. Okay? So critical attributes to remember, all these have inequality symbols. There they are. It needs to have only one unknown variable. There it is. And no exponents greater than 1 on the variable, because then it becomes a quadratic or cubic or whatever the case. From there, I give you guys steps, and I said it's the same steps we've been using for solving equations. Now we're going to use it to solve inequalities. Step 1, simplify. And that means simplifying each side by getting rid of grouping symbols and combining lines. Isolate the variable, which means you need to leave the variable by itself using inverse operations. Step 3, plot your solution on the real number line, which for inequalities, we need to plot and graph our solution. And the last one, we're going to check our solution by substituting in and make sure it makes the inequality true. So I take you back to when we introduced equations, and I gave you guys a scale. And I said, as soon as we add a weight to one of the sides, that side drops. So now, the original position of that scale was about, let's see, about right there, right? So if that was the original position, and now it drops to right there, and we said, oh yes, it forms an arrow. Do you guys see the arrow? And some of you still don't see it. And I said, check this out. Let's say I have over here 8, and over here I have 0. And look at the arrow it forms because this one is heavier. Now let me write it with smaller symbols. 8 greater than 0. Do you guys see the arrow now right here? Yeah, there it is. But as soon as I add weight to this side, it's going to balance out. So now notice that I have 8 and 8. And if the original position was like this, if the original position was like this, And when I moved it, it went down, and all of a sudden I added the same weight to the other side, and it went back to its original position. What does that look like? An equal sign. That is correct. And once again, when they are both balanced and they have the same amount on each side, therefore it's an equation. But what if I add now more weight to this side? There it goes. So therefore, the original position of the scale was over here. And now, because of this side being heavier, now the scale dropped like so. How does that look with numbers? Well, we have 8 over here and 11 over here. And what is my symbol? Yes, 8 is less than 11. Okay? So that's where we get our symbols. They come from a balance on equations, or if it's not balanced, then it becomes an inequality. So with that, signs that we will be using. So here they are. This one means less than. So that arrow pointing to the left is less than. This one pointing to the right is greater than. However, as soon as you see this less than and they add the little or part of the equal sign underneath, you guys see that? That's where this is less than or equal to, because of that little dash right there. Same thing over here, greater than, same one as this one, but here they add a little dash here for an equal sign. That's why it's greater than or equal to. And this one is not equal to. And of course, we're going to start writing our solution set using brackets. We've been using that already, using it to solve equations, and we've been using them for solving absolute value equations. So with that said, we go to our table, and in our table we have a graph here. So we're going to write our inequality using algebra. So let's see. It says here, we see a graph, and it starts at 5, and it goes to the left. See the highlighted red? And I said, all it says that all that is highlighted, that means that all those are a solution set. So now, the arrow indicates that all those continue that way. The arrow indicates it continues going that way. So I start here, and I continue going to the negatives, and it continues going to -5, -4, and so on and so forth. I'm sorry, -5, -6, all the way to negative infinity. So if I asked you to pick a number between here, where it starts, all the way to infinity, negative infinity, and I'm not a magician, I wouldn't know which number you picked. So since I don't know, I'm going to say that all these, I'm going to label these an unknown variable. Okay, so the variable I usually use is x. And where did I start off? At 5. So I'm going to write it right here, x and 5. I'm going to leave the space in between. So now, I want to fill in my inequality symbol. So let's see. If I was to pick any number here, because the x represents all these numbers, right? If I was to pick any number, and hypothetically, let's say I chose a number, let's say -23. So if I was to substitute -23 right here for the x, -23, right? Because it's part of this shaded. So now, looking at -23 and 5, which one is greater? -23 and 5. You're right. The 5 is greater. So if we were to read it from left to right, let's see, -23 is less than 5. Is that true? Yes. So if I was to ask you to pick a number on all this area, and you pick your own number, let's say you pick 2.75 negative, which is somewhere around here. When you place it here, then we would say -2.75 is less than 5. So what I'm saying is that any number that we pick from here is going to be represented by x. So therefore, this is x is less than 5. So your arrow should be like so. Now, in words, what does that mean? Well, we know that this is a real number line, right? So if this is a real number line, that means that all these are real numbers. So let's read it. X represents real numbers. So this should read all real numbers, that's what the X stands for, less than what? 5. Yeah, and that should go right here. All real numbers less than 5. All right? So now, let's do the next one together. So let's see. Which is my number that we start off with? -1. And all these, we said, could be represented by which variable? That's right, x. So therefore, I'm going to write x and -1, and I'm going to leave my space in between. So once again, for the x value, I'm going to choose whichever number I want. So let's say I just chose 23, and I substitute that in here. So let me read it. If I was to substitute in here, 23, and I'm going to read it from left to right. 23 is what compared to -1? That's right, it's greater. So therefore, any number that we choose in here that is represented by x is greater than -1. So your arrow should be pointing that way. And if we were to write this in words, if this one is all real numbers are less than 5, then this one is all real numbers are greater than -1. All real numbers greater than -1. So you write that down. Now, before I move on, who sees that, check this out, that the 5 on this one, they did not plot the point, it's open, and this one is open. You guys see that? Right. So if these are open, notice that these do not have the little equal sign underneath. Just keep that in mind. They don't have the equal sign underneath. Okay. So let's do this one together. All these numbers are represented by which letter? Good. A variable, I'd say x. And where does it start? At +1/2. So my two numbers that I start with is x and 1/2. There it is. So if I was to take any of these numbers over here, once again, and for this one, let's say I chose right here, -2.3. Somewhere right here, -2.3. All right. So I'm going to read it from left to right. -2.3 is what compared to 1/2? -2.3 is, that's right, less than. So that means all these represented by x are less than 1/2. Are we there? Good. However, who notices that this one, they do plot the point here on 1/2? Right. And if they do, that means underneath here, check this out, we need to write our equal sign because it does include this point. So check this out. These do not have it included. That's why it doesn't have the equal sign. This one does have included. That's why it has the equal sign. And how does this read? All real numbers are less than or equal to 1/2. That's true. That's where it goes. Okay? See if you can do the next one by yourself. This one. See if you can do that one by yourself. Go. Okay, so let's see. So we see that we start at 0, and all these are represented by a variable, and then we're going to say x and 0. Is that correct? X and 0. There they are. X and 0. So if I was to choose any number from over here, which is represented by x, we say that all these numbers are what compared to 0? Okay. That's true. Greater than. Greater than. However, do we include the little equal sign? Yes, because this one is plotted. You see how it includes the 0? So therefore, underneath here, we need to include the equal sign. And in words, what should it say? All real numbers are greater than or equal to 0. All real numbers are greater than or equal to 0. Okay? So far, so good. And that's pretty much it. Right now, we wrote our inequality using the graph. Now we're going to go the other way around. I'm going to give you the inequality, and I'm going to ask you to graph it. So check this out. Copy this one, example 1, and it says graph each inequality. M is greater than or equal to 3/4. So here we go. I'm going to get a number line. I'm going to do that in blue so you can see it. Okay. There it is. And I got 0 right here. Then I got 1, 2, 3. Over here I got -1, -2, -3. -1, -2, -3. 1, 2, 3. So first of all, where's my initial point? At 3/4. 3/4 is about right here. 3/4. Okay. However, does it have the equal sign? Yes, that means I'm going to plot my point right there. Plot my point. Okay? So now, since I plotted my point there, now I just need to read this. It says, m is greater than 3/4. What numbers are greater than 3/4 from the ones that you look at here on the number line? That's right. 1, 2, 3, and everything this way. So therefore, you need to shade all this area over here as your solution. And make sure you draw an arrow at the end. Okay? Now, to be specific, now check this out. One thing that I was about to forget, but no. I want you to label, let me go back to the previous screen. Sorry. When we get to these, from now on, I want you to label this one, and I'm going to label this in blue. Label with an arrow. Okay, label this. This, from now on, we're going to call it the dividing point. Why is it called the dividing point? This one's a dividing point, this one's a dividing point, this one's a dividing point, this one's a dividing point. Because it divides the number line into two sections. It divides it into, let me do that in red, solutions. 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 And the other part that it divides into is this blank space over here. This is no solution. No solutions. And the same thing with these, no solutions. And no solutions. Does everyone understand? So therefore, it's called the dividing point because it divides the number line into two sections, no solutions and solutions. So now back to our problem at hand. So we already graphed this one. There it is. Let's see if you can do this next one by yourself. Okay? Here you go. Okay, copy this one. And this is example 2. All right, here we go. So let's simplify this one. If I follow my order of operations, so here, and here you can distribute the 5. However, I'm going to simplify first inside. So to simplify this, let's see. This becomes -1 plus 3, that becomes 2. What is 5 times 2? That's 10. So therefore, this says t is less than 10. So on my number line, here's my number line. What's my dividing point? 10, which is right here. Does it include the point? Let's see. No, it doesn't have the equal sign, so we just circle the spot. There it is. And t represents all the numbers. Let's see. Any number less than 10. What numbers are less than 10? That's right. All these numbers over here. So that means we're going to shade everything to the left. You guys see that? Okay. All right. Let's see if you can try it. Try these next two. Okay. So let's look at the first one. This one says C is greater than 2.5, so you get your number line. And at 2.5, does it include the point? No, it's circled only. There it is. And it says C is greater than 2.5. What numbers are greater? All the ones to the right. So this one, using order of operations, Do we have parentheses? No. Exponent, yes. What is 2 squared? 4. What is 4 minus 4? 0. There it is. So 0 is greater than or equal to W. So my dividing point is at 0. So let's see. Here's 0. Does it include it? Yes. That's why it's shaded. So let's see. 0 is greater than W. So what number does W have to be in order for 0 to be greater? All these to the left. Okay? All right. So now the next thing I told you to actually read on the in the book was this next part, because we're going to get to some word problems, and things that you need to remember is that whenever you see a word problem and it says no more than, therefore it's going to be which symbol? Less than or equal to. So whenever you see no more than, you need to remember that it's going to be less than or equal to. Whenever you see at least, means greater than or equal to. So for right now, think about those two. Whenever you see a word problem and it says no more than, then you're going to write the symbol less than or equal to. At least means greater than or equal to. So let's go to our first word problem. There's a cellular company called Verizon. I know, it's awesome, huh? Verizon Cellular offers free minutes for no more than 230 minutes per month. Define a variable and write an inequality for the possible number of free minutes. Graph the solution. Let m equal the number of minutes. So right away, we can underline stuff that we see. Let's see. Verizon 3 minutes for no more than. What symbol does that represent? Let me go back to the previous one. No more than means what? Less than or equal to. So therefore, I'm going to write my symbol, less than or equal to, because that's what this means. Yeah? What variable are they asking me to use? It says let m represent the number of minutes. So where does that go? Yep, right here. All right. And how many minutes are they talking about? 230 minutes, and that goes right there. So let's see if it makes sense. Define a variable and write inequality possible 3 minutes. So therefore, it says Verizon Cellular offers 3 minutes for no more than 230 minutes per month. So therefore, all these minutes, all these, doesn't matter what they are free as long as you are less than or equal to what? 230. Very simple? Yeah. Let's see, you do this next one. Ray's dad told him not to turn on the air conditioner unless the temperature is at least. At least. Okay, that's key information. All right? So at least, let me go back a couple slides. What does at least mean? It means greater than or equal to. So right away, we know we're going to write our greater than or equal to sign. Okay? And it says define a variable and write an inequality for temperature in which Ray can turn on the air conditioner. Graph the solution. On this one, we're going to graph the solution. So let's see. So what letter can we use for temperature? Okay, see, there it is. How many degrees? 85 degrees. There it is. Okay, let's graph this. Here's my number line. We have 0 right here. And then we got 85 is over here, our dividing point. Does it include the point? Yeah, it's got the equal sign, so I'm going to plot my point right here. There it is. And then it says T is greater than or equal to 85. What numbers are greater than or equal to 85? 86, 87, 88, everything this way, right? So that means we're going to shade everything from this point that way and put an arrow at the end. Does that make sense? Yeah, right? So everything from this point to that side and put an arrow so that we know that includes all those. All right? All right, and that pretty much is the lesson. So for homework, make sure you work on pages, let's see, page 139 and we're going to work on numbers 6 through 17 and 22 through 33. All right, guys. Have a good one. Enjoy your homework, and I'll see you guys tomorrow. All right, bye.